Welcome, pre-cal students, to the review for the fall semester. Let's go ahead and get started. Go ahead and copy this first problem down, please. In this example here, we are trying to review what standard position of an angle is, okay? So go ahead and copy this down. I want you to remember how to write an angle in standard position. So here we go. First of all, students, don't forget when dealing with radians, this would be 0, this would be pi over 2. Or in other words, I'm going to make that 1/2. That's a lot easier to see. 1/2 pi. This would be pi, and this would be 1 and 1/2 pi, or 3 pi over 2, and this would be 2 pi when you go all the way around. So first of all, when you go to draw this angle in standard position, remember the initial side always starts here on the x-axis, and then you're going to rotate negative, so you're going to rotate down. Now, as you rotate down, you want to go to 2 pi over 3 radians, okay? Now think about that, students. Every time you go a quadrant, that's a half, okay? So if you're going this direction, it's a half, then a whole, then 1 1/2. If you're going this direction, like this, well, there's a half, and then a whole, and then 1 1/2, and then 2, okay? So one way to do this is to leave the problem in radians, and just go like this. There's 90 degrees, that's a half a pi, and then a little bit more would be 2/3, so about right there, and then draw your angle, and that's totally fine. Probably an easier way to do this would be to go ahead and convert this over to degrees, okay? And so we would have negative 120 degrees. And so start here, we go 90 plus 30 more is negative 120. But there's the angle written in standard position. Standard position means the vertex is at the origin. The initial side is the positive x-axis. And then, of course, you rotate to where your terminal side would be. Okay? Make sure you know how to write angles in standard position. Alright, make sure you can take a calculator and find the cotangent. Or for that matter, make sure you can take a calculator and find the tangent, sine, cosine, tangent, cosecant, secant, cotangent of an angle, okay? Now, first of all, make sure your calculator is in degrees, and you do that by going to the mode button, which is the top left side, okay? And pushing that, and then scrolling down and highlighting degrees, okay? So make sure you do that. Now, after you've done that, realize there's no cotangent button on your calculator, so you want to type into your calculator tangent of 53 degrees, okay? Go ahead and do that and hit enter. When you do that, you will come up with this right here, 1.327044822. Now what you want to do, students, is you want to flip that, and the way that you flip it is to use the button. It's the far left column, fourth button down from the top. Far left column, fourth button down from the top. It's X to the negative 1 button, okay? So after this is on your screen, you type tangent 53, enter, and this pops up. Then you want to flip this to give you the cotangent of 53. So you hit this button here, and when you do, this will pop up on your screen. Answer, negative 1. Go ahead and hit enter, and it flips that for you, and the answer should be 0.7536 rounded, okay? Now, if you got to back this up and watch it again, then please feel free to do that, okay? Alright, moving on. You should also be able to use a calculator to find a missing angle, okay? So, we are trying to find the angle that when you take the secant of it, you get 2.4. Now, here's the problem with that. Notice that nowhere on your calculator is there a secant button. So here's what we're going to have to do. We're going to have to flip both sides. So if you flip secant, you get cosine. And if you flip this, you get 1 over 2.4, because 2.4 is over 1, and you flip it. So now I can definitely type this into my calculator. Now don't forget, when you're looking for an angle, second, and then cosine. And when you do that, this should pop up on your screen. Then hit 1 for your numerator. Then hit divided by. And this will pop up. And then 2.4. And then close the parentheses. If you do that correctly, you will get this for your answer. 65.4 degrees. Now, what if I wanted you to give an answer in radians? Okay, no problem. Before you type all of this in, go back to your mode, okay, and convert over to radians. So go to the very top, almost far left, you'll see mode. Go down and highlight, push mode, and then highlight radians, and then come out of that. And now do the same thing again. You're in radians, so hit second cosine, okay, and then 1 divided by 2.4, close the parentheses, and you'll get this for an answer, 1.14, okay? So there we go. Know how to do this stuff, okay? Alright, moving on to the next problem. Okay, now we're going to label the lengths of the three sides of the right triangle, and then just simply label out our sine, cosine, tangent, secant, cosecant, cotangent, okay? So I'm telling you right now, the cosecant of theta is 4/3. Now students, listen, it doesn't matter if you put theta here, or if you put theta here, as long as you leave it there and don't move it, okay? So I'm going to put theta up here. Now, cosecant, now let's think this through. Cosecant of theta is 4/3. Now, if you remember the ratios I taught you, cosecant is hypotenuse over opposite. Okay? So, my hypotenuse will be 4, and my opposite side from this angle will be 3. So now, pretty easily, we can find this last side over here by using Pythagorean's theorem, and I believe we'll get the square root of 7. Alright? Now, moving on, very quickly, let's find the sine of theta, opposite over hypotenuse, 3/4. Let's find the cosine of theta, adjacent over hypotenuse, square root of 7 over 4. Tangent, opposite over adjacent, so we get 3 over square root of 7. We're going to rationalize that, and we'll get 3 square root of 7 over 7. Okay, secant would be the reciprocal of cosine, so we get 4 over square root of 7. We're going to rationalize that, so 4 square root of 7 over 7. Cotangent would be the reciprocal of tangent, so if we flip this, we get 7 over 3 square root of 7. Alright, so if we rationalize that, we'll get 7 square root of 7 over 21. Let me show you where I got that so there's no confusion, okay? Let's bring this down here. Let's erase this. Okay, we're going to multiply the top and the bottom by the square root of 7, okay? So here we go. 7 times the square root of 7 is 7 square root of 7. Now there's a 1 in front of this radical, so 3 square root of 7 times 1 square root of 7. 3 times 1 is 3. Square root of 7 times square root of 7 is square root of 49. Of course, the square root of 49 is 7, so I really have 3 times 7, which gives me 21. So 7 square root of 7 over 21. Now these two numbers here can reduce, so I would have 1 square root of 7 over 3. And if you don't want to put that 1 right here, you don't have to. Okay? There we go. So make sure you know how to do this. This is pretty basic trigonometry, but make sure you know how to do this, okay? Alright, moving on. If a circle has a radius of 3 units and an intercepted arc of 6 units, find the measure of the central angle. Give your answer in degrees. Okay, students, first of all, let's go over the formula that you need to know, okay? A central angle of a circle always equals the arc that is intercepted divided by the radius. Now I think they use some different letters, and I think I give you some different letters, like S over R or something like that, but this is good enough, okay? So, there's the formula you need. Make sure you know that for your exam. Now, one thing you need to know, this central angle always has to be in radians, or when you use this formula and you get out an angle, it will always come out in radians, okay? Alright, so having said that, let's go ahead and use this angle, or this formula. Here we go. If a circle has a radius of 3, so I'm going to go ahead and get rid of this radius here. And an intercepted arc of 2, or of 6. So my arc is 6. Find the measure of the central angle. Well, that's easy. The angle would equal 2. But that's 2 what? Radians. And I want your answer to be in degrees. So remember, anytime you're converting an angle from radians to degrees, you take that number and you multiply it by 180 over pi. Okay, so very quickly with my calculator, 2 times 180, put this over 1, is 360. 1 times pi is pi, so 360 divided by pi gives me 114.59 degrees. 114.59 degrees. Okay, now students, can I say something to you? Please, please don't miss this. Know this formula well for the test, okay? Make sure you know it, because I'm going to tell you now on the test. I might not give you the radius and the arc. I might give you the central angle and the radius and tell you to find the arc. Or I might give you the central angle and the arc and tell you to find the radius. And what if I give the central angle to you in degrees? Then you've got to convert it over to radians and then put it into the formula. So just make sure you're very familiar with this type of problem. Okay, moving on. Convert the given radian measurement to degrees, okay? Anytime you're given radians, whether it's written in terms of pi or not, it doesn't matter. Anytime you're given radians, if you're going to convert it over to degrees, you always multiply it by, like I just showed you a second ago in the last problem, 180 over pi, okay? So here, your pi would cancel with your pi. 5 goes into 180. 36 times. Bring over your negative sign, and we have 6 times 36, which would give us 216 degrees. So there's the answer, negative 216. Okay, moving on. Now, convert the given degree measurement to radians. Your answer needs to be written in terms of pi. Okay, no problem. That means your final answer must have pi written in it. Okay, so 80 degrees. Well, listen, students, anytime you're taking degrees and converting it over to radians, you multiply it by not 180 over pi, but pi over 180, okay? So put this over 1. 80 times pi is 80 pi. 1 times 180 is 180. Now, with your calculator, just simply reduce that fraction, which is really pretty simple to do, and you'll get 4/9. So your answer is 4 pi over 9. Okay, 80 over 180 reduces to 4 over 9. Now students, what if I would have asked you to write your answer in decimal form? That's so easy, guys. Simply take 4 times pi, enter, divided by 9, enter. So take 4 times pi, enter, divided by 9, enter, and you'll get this, 1.396. So, here's your, both of these answers are in what? Radians. Both of them are in radians. One is written as is a decimal, and 1 is written in terms of pi. Either way is the same answer. Just do whatever the instructions tell you to do. Okay, moving on to the next problem. Be ready to do some simple word problems on your exam when it comes to trigonometry. And you can say this will not be a difficult problem, but just simple right triangle types of trigonometry. Make sure you're ready for those for your test, okay? So here we go. A guy wire runs from the ground to the top of a 25-foot telephone pole. So here's the ground. Here's the telephone pole. Here's the guy wire, okay? The angle of elevation from the ground to the top is 52 degrees. So, angle of elevation, you always need a horizontal line. And then elevation means the line going upward. So here's your angle of elevation right here. It's 52 degrees. And the telephone pole is 25 feet tall. How far from the base of the pole is the wire attached to the ground? So how far from the base of the pole is the wire attached to the ground? So here's the ground. How far is the pole right here to where the wire is attached to the ground? So we'll call this X. Now we have a right triangle, so very easily we can say 52 degrees. We have opposite and adjacent. So I'm going to use tangent, okay? So tangent of 52 degrees equals opposite over adjacent. Multiply both sides by X. And you'll get this right here. Now divide both sides by tangent of 52. And here we go. So 25 divided by tangent of hold on 1 second, students. Sorry, my calculator is messing up. 25 tangent of 52. Enter is oh, and you know what, students? I'm still in Radians, so make sure you don't make the same mistake I did. Okay, I'm in degrees. Let's try this for the third time now. 25 tangent of 52 would be 31.99, or we'll just say 32. So this whole length here is 32 feet. Okay, now, what is the angle of depression from the pole, from the top of the pole to the ground? So here's the top of the pole. In order to have an angle of elevation or an angle of depression, you must have a horizontal line. So if we're going to have an angle of depression, we must sketch a horizontal line. Now the angle of depression from the top of the pole to the ground would be right here. That angle there. Okay? Now that's pretty easy to figure out because inside your right triangle right here, we already know 3 angles. So we can find that third angle pretty quickly. 52 plus 90 is going to give you 142. And so then the third angle has to be 38 degrees to give you 3 angles that add up to 180. Now, look students, this is a horizontal line, correct? Sure it is. This is a vertical line, correct? So that means we have what angle right here? We have a right angle. So if this is 32, then this has to be 52 degrees right here, okay? Because 52 plus 38 is 90 degrees. So what is the angle of depression? 52 degrees. So be able to do some simple trick word problems like that. Okay, moving on. The point 43 is on the terminal side of an angle. In standard position, determine the 6 values of the 6 trig functions. Now students, listen, we're just kind of reviewing here what these terms mean, okay? First of all, we have a point that is lying on the terminal side, -4, +3, right here, okay? So there's the point lying on the terminal side of an angle in standard position. So here's the angle. I'm going to switch colors here. Here's the angle in standard position. It starts here, and then it goes up to here, right here. angle right there. Okay, now determine the exact values of the 6 trig functions of the angle. So please listen to me carefully, students. Here's the angle. We're going to call it x. We're trying to find the 6 trig values of that angle x. Now that's going to be pretty hard to do, okay? But hold on a second. Remember, students, if I'm trying to find the 6 trig values of this angle here, I can always use the reference angle, which is this angle here, as long as I remember that sine is positive, cosine is negative, and tangent is negative. So since I don't know what this angle here is, I'm going to go ahead and find the sine, cosine, and tangent, cosecant, secant, and cotangent of this angle here, as long as I remember my sign changes. So I know I can draw a right triangle. And I know this point, this triangle has a length here of 4, because I'm over 4, and it has a height of 3. So the hypotenuse, if I use Pythagorean's theorem, is going to be 5. Now we are really home free. This is so easy. So the sine, we're going to call this angle y right here. So the sine of y would be opposite over hypotenuse, 3/5. Okay. The cosine of y would be adjacent over hypotenuse, and notice cosine's negative, so negative 4/5. Alright, and the tangent of y would be negative 3/4. Negative 3/4, because tangent is negative in quadrant number 2. Now, students, let's quickly find our last 3 trig functions. If this is sine, then the reciprocal would be cosecant. So the cosecant of y is 5/3. Secant is the reciprocal of cosine. That'd be negative 5/4. And cotangent is the reciprocal of tangent, which would be negative 4/3. There we go. Okay, so not too difficult. Alright, moving on. Finding reference angles. Okay, this will be good. Now, let's first of all deal with our degrees, okay? Here's a coordinate plane. I have an angle that is 71 degrees. Well, the reference angle always starts here and goes to the terminal side. Okay, so there we go. I mean, I said that wrong, and I apologize. Sorry, guys. Well, let me say that again. Okay, the reference angle is the angle that's formed, the acute angle that is formed with the x-axis and the terminal side. And so the reference angle for 71 is just going to be 71 degrees, because here's your terminal side, here's your x-axis, and so it would be 71 degrees. Now let's talk about 250 degrees, okay? Okay, I'm going to travel 90, 180, plus 70 more is going to be 250. There we go. Now, what is the reference angle? Well, guys, I just said, find the terminal side. Here's the terminal side. And then you want to find the acute angle that is formed between the x-axis and the terminal side. Well, that's going to be this angle right here. There's your terminal side. There's your x-axis, this little angle here. So I know I went 180 plus 70 more to give me 250. So this angle here has to be 70. Okay? Now let's deal with radians, okay? Now be really careful here. We know for sure we want to move 7.1. Now remember, guys, if you go around once, that's 6.28, okay? How do I know that? Because every time I move 90 degrees, I'm going 1.57. How do I know that? Pi over 2. 3.14 divided by 2, 1.57. So every time I travel 90 degrees, I've traveled 1.57 radians. So if I go all the way around, that's 6.28. Okay? Now, how much further do I need to go? Well, let's see. to here. And that's going to be 0.82. So the reference angle is the angle that's formed by the terminal side. Here's my terminal side. And the x-axis making an acute angle, so this much here. This little angle here. Well, that little angle there is going to be 0.82 because one rotation is 6.28, and then 0.82 more gives you 7.1. So the reference angle is 0.82. Now, what about 2 pi over 3? Okay, well, you can leave it in radians or convert it over to degrees. Okay, but it would be pretty easy to do if we converted it over to degrees. So 3 would go, let's see, convert this over to degrees, we get 120 degrees. So here's 2 pi over 3 is 120 degrees. So it looks something like that. There's the terminal side right there. Okay, now the reference angle for this angle is always the angle that's formed with the terminal side, and it has to be an acute angle formed with the x-axis. So there it is. So we'll call this y. So you moved 120 degrees. So what's left over right here? 60 degrees. So the reference angle would be 60. Okay? Alright. So make sure you know how to find reference angles. Alright, moving on. First of all, we're going to find the sine of negative 4 pi over 3. No decimals allowed. This will be interesting. Here we go, okay? Alright. Negative 4 pi over 3 would be negative 240 degrees, okay? So I'm going to go ahead and slide this down so there's no confusion as to what problem we're doing. We're solving this problem here. There we go. Now, negative 4 pi over 3 is negative 240, okay? So I'm going to rotate negative 240. There's 180 plus 60 more. There we go, there's negative 240. Now guys, think about that. I just went 180 plus 60 more. So if I want to find the sine of this, I can really just use the sine of what right here? 60 degrees. That's the reference angle. Okay, here's the reference angle for 240 degrees, or 4 pi over 3. So I can find the sine of 60 instead of the sine of this, as long as I remember that the sign up here for sine is positive. Okay, so the sine of 60, well, think about our special triangles, guys. Okay, this is 30, this is 60, this is 90, 2, 1, square root of 3. So what is the sine of 60? Well, opposite over hypotenuse, so pretty cool. Square root of 3 over 2. There it is. Okay, no decimal answers, guys. Alright, don't forget you really should know your special triangles for the exam, okay? You really, really should. That's very important to be able to do. Know your special triangle is very important. And hold on 1 second, students, while I look at something here. I might have left something off the test here, so hold on 1 second. No, we are good. Okay. Alright, moving on to the next question. Alright. Find the cotangent of theta if cosecant is negative 9/4 and the terminal side of theta lies in quadrant 4. So here we go. I know I'm in quadrant 4. So I go all the way to here. I'll go ahead and draw a right triangle here. I know I'm in quadrant 4, okay? Now they're telling me, excuse me for yawning, they're telling me the cosecant of this angle here, we'll call it theta, is negative 9/4. Now think about that, guys, come on. The cosecant of an angle is what? The reciprocal of sine. So it would be hypotenuse over opposite. So here's my angle. The hypotenuse is 9. using Pythagorean's theorem. Let's find this third side really quick here. So I'm getting square root of 65. Now remember, I can take the cotangent of theta by using this triangle, as long as I remember that the signs here are negative, positive, negative. So if I'm going to find the cotangent of this angle, my answer will be negative because tangent is negative. So my answer is negative. Now, the cotangent of this would be, let's see, tangent is opposite over adjacent. Adjacent, so cotangent would be adjacent over hypotenuse. So square root of 65 over 9. Okay, let me get a drink here real quick. And we'll continue on. Okay, here we go. That's problem. Okay, we're going to find two exact solutions for this. Now, students, right away I'm noticing I see square root of 2. Okay, so I'm thinking, okay, maybe I'm going to use my 45, 45, 90 triangle. Okay. Now, when you draw the special triangle, we call this leg 1. This leg 1, using Pythagorean's theorem, we get square root of 2. And that's why I knew to use the 45, 45, 90 triangle, students, because I noticed right away we're dealing with a square root of 2. Now, students, this is a pretty tough problem, because when you look at this, you're thinking, okay, where's my 2? And there's no 2's. There's a 1 here and a 1 here. So what are we going to do? Well, guys, think about this for a second. Probably the cosine of this angle here. We're trying to find this angle here that gives us this. Think about it, guys. Come on. More than likely, the cosine of theta was not square root of 2 over 2. It was probably 1 over square root of 2. Okay? And then we rationalized the denominator, and we ended up with square root of 2 over 2. So what angle out of this triangle here will give me 1 over square root of 2 when I take the cosine of that angle? Well, this angle right here, because the cosine of 45 is adjacent over hypotenuse. So the angle here has to be 45 degrees. But here's the problem. Please, please don't miss this, students. I want to take the cosine of an angle so that I get out a negative number. So we got to figure out what quadrant I'm in, okay? Cosine is negative here and here. So there's my two quadrants. So I'm going to put a triangle here and a triangle here. And then on the inside, I'm going to put my angle that I already figured out was going to help me, and that's 45 degrees. Okay, so really, I'm going to start here and go to the hypotenuse. I get 135. So the cosine of 135 does give me negative square root of 2 over 2. So 135 degrees. Now the other answer would start here and go all the way to the hypotenuse. So that's 180 plus 45. So 225 degrees. Okay? Alright, not too bad for a first day of review. I hope this has made sense to you. You need to study this information and be ready for your test next week. Call or email if you have any questions. And that's the wrong thing. Hold on a second here. There we go.